Okay, so we'll move on to the second part of this, right? So far, we have learned a couple of things. We've learned 5 things, essentially. We learned what is a vector. Essentially, we take the geometric view, right? So that's the motivation, and that's fundamentally what a vector is an arrow, okay? And we learned that it has 2 properties, it's 2 key properties, right? It has a magnitude and a direction. That's the property of arrows, or the mathematics of arrows. And then we learned how to add them geometrically. We put them head to tail, or sort of the triangle rule of addition. We learn how to subtract them, and we learn how to scale them, or scale multiply for in full, right? Sometimes for short, we just call how to scale them. If you multiply a vector by 2, you basically stretch it by 2. If you multiply it by 1/2 or 1/3, you basically stretch it by 1/2, or what that means is you shrink it, right? You just shorten it by that amount. So you kind of know how to take a arrow and divide it or multiply it by a scalar, by a number. A scalar is the same as a number. We haven't talked about how do you multiply vectors with vectors, so arrows times arrow. We haven't quite talked about that yet, and in fact that is very complicated. We'll defer that a little bit later, yeah, we'll move on. We also introduced 2 new terms. What's a unit vector? It's basically a vector with unit length, right? A 1 unit of length, and we use the notation. So we've introduced these notation. That's a standard vector. That's a vector that is specifically with 1 unit. And we've introduced base vectors, which is unit vectors that lie along the coordinates, right? So we've learned I, J, K, okay? So these are sort of some notations we've learned. Okay, so now with that in mind, we're ready to look at a different view of it. Which is much easier to deal with instead of drawing a lot of pictures in order to do math with these vectors. So first of all, let's see what we mean by this. So if I have a vector like this, as soon as I introduce a coordinate, I can now transform it into a different way of referring to it, right? So let's put this on a coordinate. So I'll draw some grids over here, right? So the usual thing, this is X, right? So this is the X direction, this is the Y direction, and I'll put some grids like this here. Okay, all right, so this is my vector, let's call it A. And remember, we also know what a base vector is. A base vector is from the starting point, right? 1 unit to the right, that's I, and 1 unit to the top, that's J. But now you can find a relationship because you know how to add vectors, right? So I realized that A is basically made out of 1, 2, 3, 4 units of I, plus, remember if I add them head to tail, right? So 4i just means this, right? I plus I plus I plus I. And then I'll go how many units upwards? 1, 2, 3, 4. It happens to be 4 as well. 4j, like this. And now I can write A in terms of I and j, right? It's made out of 4 i's, right? 4 units to the right in the x direction and 4 units to the top in the j direction or the y direction, like that, right? So this is called the component form, right? So we have the geometric form, sort of the pictorial or geometric form, like this. That's literally drawing it out. And now we have a separate way to write it algebraically in what's called the component form. And these are now called components, right, of A. So this is the X component and this is the Y component. It has 4 units of X direction and 4 units of Y direction, right? Sometimes we're so lazy, we can even simplify that and write it as a column, like this. And by default, the first entry, maybe I should, let me just tweak this a little bit, right? Let me add one more so we can distinguish the X and the Y, right? So let me just add one more unit there. So it's 1, 2, 3, 4, 5, right? So A is made out of 4 i's and 5 j's, right? So I can write it like this, right? So this is called in component form, and this is called in creatively column form. Okay, so it's column either column representation or column form of a vector. Okay, so as you can see, you know how to add and subtract vectors. You can see that A is literally made out of, right, 4i plus 5j, like that. Okay, there's one more way to represent this, or to write it or to represent it. It's called a row form, and the reason is because this is also very difficult to type in a computer. So if you're typing, a lot of textbooks would write it like this, 4, 5, just as a row. And this is the row form or the row representation of a vector. So all these three are sort of called algebraic because you break them into components. Okay, so like I said, these are called base vectors. And if it's a plural, the whole set together, sometimes it's called a basis. You can use them interchangeably, right? So the I and the j is a base vector. The 4 and the 5 are called components, or the vector components. Okay, the vector components themselves are just numbers or scalars, like that. Okay, in particularly, 4 is called the x component of A. The 5 is called, you can guess it, the y component of A, right? So x component, y component, x component, y component. And slightly abstractly, you can see that in general, sometimes people will write it like this with a subscript, right? So that's the x component of A, the y component of A. You can write that in column form. You can write that in row form. Sometimes people will put a comma. I don't want to do that because it confuses with coordinates, but sometimes you'll see that. And there's the component form as well. You can write them explicitly in components like this, okay? So just for completeness, right? So in 3 dimensions, you can also start to talk about using this component form, or one of these component forms in 3 dimensions, right? Okay, so yeah. So for 3 dimensions, you can also have, for example, a vector, and this would be how many units, right? So that number of units in the x direction, that number of units in the y direction, and that number of units in the z direction. Okay, so you can write it as a column, you can write it as a row. All of these are valid ways to write. Okay. And to let you know, personally, I like this the best because I don't have to write the IJKs every time. And it's also very visual to do some manipulations, as we'll see. Okay, all right. So the next question is really to how do we go between this algebraic form and the geometric form, right? So I kind of showed you if I give you the algebraic form, you can easily write out the geometric form. But how do we go the other way? So let me use a separate video to address that, okay?